How's it going, class? Today I'm doing my final place of interest on the Mammoth Mountain and Devil's Postpile. So here is my photo of inspiration. It's a photo I took while backpacking the John Muir Trail. Right now we're in the backside of Mammoth Mountain overlooking Garnet Lake. And then to get a better look at it on a map, over here is Devil's Postpile, and then hiking up is where I went, and then I took the photo right about here overlooking Garnet Lake. And then over in this photo, you can see where Devil's Postpile and Mammoth are in correlation to each other, as well as some other national park territories and things like that. So what is Mammoth Mountain and Devil's Postpile known for? Well, they're both unique rock formations that formed around 50 to 100,000 years ago. It is still an active system, and you can see evidence of that here. Being that it is an active system, gas is coming from underground up to Earth's surface in the form of CO2, and it's actually killing a lot of trees, as you can see here, a lot of dead trees. Like I said, the unique rock formations in this photo, it's Devil's Postpile. The large pillars and columns of basalt rock give it that very, very unique look. And then over in this photo, you can see the lava dome complex. I believe that's all obsidian from cooled lava. So through my dominant rock investigation, I found that the dominant rock type is mafic igneous rock, and the dominant rock type name is basalt. Both features were formed around 50 or 80 to 100,000 years ago when lava erupted from the active volcano and cooled on itself. And the rock that formed is primarily basalt, rhyolite, and dacite rocks, though Devil's Postpile on the right photo is primarily basalt. So a couple things I found in my earthquake investigation. There aren't too many earthquakes recorded, especially large ones. It is moderately seismically active, with several small, shallow earthquakes. And then you can also see that there's some deeper volcanic tremors due to it being the mountain being under, or the volcano being under the active volcano. And then it's also has deeper volcanic tremors because of the gas vents. In that previous photo, we saw the CO2 coming up from the earth. So the dominant process, it's volcanoism and cooling and columnar jointing. The dominant process occurs generically when heat and intense pressure push magma up from underground through volcanoes, and it sends lava out to Earth's surface. Then the lava cools, and then more lava comes out from under Earth and then cools on top of that. It specifically occurred around 50 to 100,000 years ago through a series of 25 volcanic eruptions. And that's, like I said, when lava would emerge and cool on top of itself until it formed this gigantic mountain, also Mammoth Mountain. And that's also how Devil's Postpile was formed. So in summary, both Mammoth Mountain and Devil's Postpile were formed from volcanic eruptions. They are primarily made of basalt, rhyolite, and dacite rocks, though Devil's Postpile is primarily basalt. Like I said, both formed around 50 or 80 to 100,000 years ago, and the site is still moderately seismically active. And then there's another photo I took, actually in Mammoth on the west side. And then there's my sources. Thank you.